So, all right, advance here. All right, okay. Well, thanks so much for having me here. We're going to have a little bit of a respite maybe from lakes and waters, although I'll come back to that at the end of my talk. But I'm going to talk about phenology. And when I talk about phenology, I usually start with the definition, since this is a term that is not necessarily in everyone's vocabulary. Phenology comes from the Greek word pheno, which means to show or to appear. And it's the study of recurring life cycle events in plants and animals. So when do trees first bud? When do they flower? When do fish spawn? So these timing events. And I like to engage the audience a little, make you think. So you guys get a quiz just to get things started. And that is, what year do you think this term was coined? 1971. Was that 1971? Okay.
1890.
1890. 1750. Oh, I'm hearing too many voices. 1813. All right. 1318. All right. Sometimes no one says anything. I love you guys already. This is great. All right. It was coined in, are you ready?
Yes.
1849. 1849 by this guy Charles Morin. He's a Belgian botanist, and he was giving a public lecture on climate and the kind of life cycles of plants and animals. However, this idea of phenology has really been part of who we are, I think, as humans in nature for the long term. This is an image, an Italian painting from the 1500s, and it's 12 panels depicting the 12 months. And if you look at what they're depicting in each month, you'll see that most of them are phenological kinds of events. Timing, when do we harvest, when are the grapes ripe so that you can stomp them into wine down in the bottom panel there. Closer to home, the Ojibwe people in Minnesota and the Lake States organize their seasons by 13 moons, and each of those moons has a name, and generally those names correspond to phenological events that are happening during each of those times. So the strawberry moon, the ricing moon, for example. Anyone know who this is? I guess it says it up there, Carl Linnaeus. So it turns out that in terms of the scientific use and study of phenology, as well as phenology as having citizens actually going out there and collecting data, Linnaeus was the first to start this. Carl Linnaeus wrote this book called The Floral Calendar, and it was a guide to monitoring plants and animals as a way of following climate. So he organized a meteorological network that used plants as the kind of signals of what was happening with climate. And early on, phenology really grew up with meteorology. So this is an image from a book from the 1700s. This is a pan-European network of botanical observations associated with climate monitoring stations. We had this in the US as well. This is results of meteorological observations conducted by the Patent Office. I haven't ever figured out why the Patent Office was involved, and the Smithsonian. This is the 1800s. And they have these sections on observation of periodical phenomena of plants and animals. And I've circled, you guys can't read that, but I've circled on there some records from here in Minnesota. So why monitor phenology? Why do we care about phenology? And one of the interesting things about phenology, and part of why phenology has really emerged or linked to meteorology, is they're kind of biosensors of climate, right? And Aldo Leopold famously, maybe not famously for phenologists, has this quote. from the beginning of history, people have searched for order and meaning in these events, meaning these timing events. But only a few have discovered that keeping records, and I hear you guys are record keepers, right? Enhances the pleasure of the search and also the chance of finding order and meaning. These few are called phenologists. So Aldo Leopold was an early phenologist in the US, and he really recognized what I saw earlier today in the wonderful presentation with the colored water, the orange hat back there, that when you collect data, when you collect records, you can see order, get meaning out of that. And so what's happened over the last 20 or 30 years in the ecology community is really, and in many communities, this question of climate change. What's happening to plants and animals? What's happened to your natural world? What, can we see signals of climate change out there? And there was questions, well, how do we do this? How do we kind of track whether or not we see signals of a changing climate in our natural systems? And what some smart folks realize is that there are all these phenology records out there. And so this is Robert Marsham, and he, on his estate in Great Britain, they have been collecting phenological data for over 200 years. And so this biologist in England said, I wonder, those plants and animals sense temperature, they sense climate. I wonder if we looked at those data, we could see change. So if the climate's changing, say it's warming, and you have data on when the leaves come out, what would you expect if you have a record of leaves coming out over 200 years for that data to look like? So think of a time series. I don't know if people think about data. Maybe not like over time. Be earlier. Yeah, so they said, hey, let's look at these data. And sure enough, they pulled out these phenological records, and they found that many things were happening earlier. And interpreted this really as a signal of plants and animals sensing these changes in the environment related to changing climates. Closer to home, Aldo Leopold collected records at the shack in Baraboo, Wisconsin, and his daughter Nina, shown here, picked up that recording in the 80s. So Aldo Leopold and his kids collected records in the 40s. She started in the 1980s until when she died. And this is just a graph showing what they found. Let me figure out the technology here. There we go. So here's this time, right? This is time 1940 to the 2000. And then this is what day it happened. So this is earlier, this is later. And you see that for a number of species, we see that earlier trend, right? They're happening earlier. But other species aren't changing. And this work for this region was important because it really illustrates that not everything's potentially responding the same. And these things occur together, right? So they're neighbors, they interact with each other, and one's changing, one's not. That could have consequences. So overall, phenology and these records that people, naturalists largely have kept, has really provided one of the most widespread and coherent signals that our natural world and plants and animals that inhabit it are responding, sensing that there's a change. Another quiz. What's the longest written phenological record of spring flowering? How many years? Right here, 200. So we saw the Marsham, 200. Anything longer than that? 500. Are there any guesses? 650. Sold to the man who bid 650. It's actually 1,200. Japan. So the Japanese celebrate the Cherry Blossom Festival every year. It's an important festival, and it is tied to peak flowering of cherry blossoms. And so they have kept records of this over time. And biologists from Boston actually thought, hey, let's analyze these data and see what's going on. And you'll see here, so there's a lot of variability, right? We have warm springs, cold springs, things change a lot. 2012, 2014, really different years if people remember those. You know, so there's a lot of variability, but look at this. We get into, you know, the current time, and this variability, one, it looks a little bit less here, but the big thing is that it's trending this way. The cherries are blossoming, you know, 10 days or more earlier than they ever have in the last 1,200 years. So pretty cool data set with what I think is a pretty clear signal of a plant sensing something changing. So in my lab, we have that question.
Yeah, that doesn't correspond to the actual temperature, right?
You mean that the...
No, because the temperature is not increasing globally.
Globally, but locally, in parts of the globe, there's definitely are trends.
Hard defining climate change. Climate change always happens. It always has. Back around the year 1000, it was much warmer than today. Carbon dioxide levels go up and down. Carbon dioxide is a good thing. Helps plants grow. If the world were warmer, we'd be all better off. Look at all the land in Russia that didn't use for farming.
Most people disagree with that.
Continue.
Scientists disagree with that.
Well, don't say it's unanimous.
Continue.
All right, I'm going to move forward and keep talking about phenology. So in my lab, we really have a saying that to everything there's a season. Seasonality is important, understanding seasonality is important. And timing is really everything. Understanding when things occur is critical for understanding how things work. So when birds return, the timing of that is critical for having insects there, for them to feed their young when they nest. So their timing is synced to those kinds of events. Why do we care about timing? Why would we care about phenology? Regardless of whether we're using phenology to say plants and animals are sensing climate change or just studying phenology for what it is, it's critical for understanding the growing season length, right? When plants come up, when they senesce, the time between those is when they, how much growing season they have. It's critical, as I just was mentioning, in terms of understanding the availability of food and nest sites when animals migrate. So having that synchronized timing is critical. It's important for understanding pest outbreaks, right? So having the timing of leaf out is critically linked to when that foliage is really tasty for some of these pests and pathogens. And so depending on how in sync or out of sync those phenological events can determine levels of pest outbreaks. It's important for pollination, right? When you have pollinators, you need to have pollen around. So having that pollinator abundance and flower abundance is critical for those services to happen. It's important for people, right? 2012, we had a really early spring, and several of our economic crops in the state, maple syrup and apples, had some struggles that year. Maple syrup, got to like 80 in March, and we had this early spring, and it was a really poor year for maple syrup. And the timing here, it got warm, so the apple said, woo, let's wake up, let's have our leaves, let's get our flowers out there, let's get going. And then we had a normal frost that year that created serious problems in terms of apple crop. And in other parts of the US, the cherry crop in Door County and in Michigan, for example, had pretty much complete failure that year because of that mismatch of timing that occurred. Timing of the phenology with the timing of that weather event that spring. So I'm going to talk about 3 different projects going on in my lab and in our group. The first one is related to looking for these kind of historical records in Minnesota to look to see how are Minnesota plants and animals changing in terms of phenology. Are they changing? So these are some of the Leopolds and Marshams of Minnesota. I don't know if any of you guys recognize any of these folks. I don't know, does anyone listen to Jim Gilbert's show? Yeah, so Jim Gilbert's there. Someone here said they had an office in Hodson Hall. This is Alec Hodson. So a number of people in the state. John Latimer, I don't know if anyone's from the Grand Rapids area, he's the Phenology show. A lot of data in Minnesota to help us understand, you know, what's going on, are things changing, and think about what does that mean in terms of some of our management. So we've been digitizing these data sets from these folks, and we have over 200 species for which we have more than 20 years of data with which to look at trends in phenology. So I'm just going to show you a few of these time series from Minnesota. This is Sandhill crane arrival, and again, this is kind of set up in the same way for people who aren't used to looking at graphs every day like I am. This is time, so it's going from 1980 to 2015, and this is the date it occurred in the spring. So we see that Sandhill cranes are coming back earlier every year. We don't know exactly the cause of this. One of the things that's happened with sandhill cranes in Minnesota, does anyone know how their populations have changed in this time period? They've gone up. Yeah, and so we think that some of the signal is really being able to detectability, right? The more that are coming back, the more likely people are to see them. But we see this earlier trend for sandhill cranes. We see an earlier trend for yellow-rumped warblers. We don't see a change in terms of Baltimore orioles. So some species are showing change, some species are not showing change. This is for people who aren't birders, this is a butterfly, the eastern-tailed blue. And this is actually, this guy is an amazing naturalist from Nevis who's been going out and collecting data on dragonflies and butterflies almost every day for 35 years. And so this species is being seen earlier in the state over the period of his record. This is one of our longest records. This is aspen leafing, and this comes from Alec Hodson, who basically every day when he walked to work on the St. Paul campus looked at a series of plants and animals and said, what are they doing? So we have this record from 1940 to 1991 that he collected, and then data that we've collected. And for aspen leafing, we see this, also this trend towards earlier. So this data set gives us basically a set of information with which to understand how these timing events might be changing in the state of Minnesota, and then to start thinking about what does that mean in terms of interactions among species, in terms of management decisions that might be made. And I always throw out the pitch at these talks that if any of you have a closet full of calendars on which you've been collecting information, we don't have much aquatic information, so if anyone has fish data or things like that, we're always happy, or if you know of someone who has been collecting phenological type of data that might be willing to share, we're always looking for new data to add to this big data set. All right, so the second question, or the second study I'm going to show is a study where we have basically are experimenting, asking questions about how do trees, common trees of Minnesota, especially of the kind of iconic Northwoods of Minnesota, how do these species respond when growing under warmer temperatures? So this question of, in a future that may be warmer in the state, what might we expect to see in terms of how well our core Minnesota species do, and can this help us predict where our forests might be going in the future? So the project is called Be Forewarned, and that stands for Boreal Forest Warming. And what we've done is planted small juveniles, so the kind of future of the forest, into these small plots. And then we have these heat lamps. So it's an outdoor experiment, open air. They're growing in kind of their natural conditions, and we're just adding a little bit of warmth and looking at how they respond. How do we warm them? We use ceramic heaters, so like you have in a space heater in a cabin or in your house, and cables buried in the soil that warm the soil. We use an approach that this is kind of going through the time of day, and this is our unwarmed plot, and then the idea is we just bump it up a little bit, in this case 1.7 and 3.4 degrees Celsius, which is about 5 and 7 degrees Fahrenheit. So, when it's cooler in our ambient, it sort of tracks the normal variation in the temperature over the course of the day and over the course of the year. And then just adds a little. And I'm going to focus on showing phenological responses to this. And these data are not surprising, but they support, using an experiment, what we see in those long-term records. So I'm going to show you a series of pictures. A picture is worth 1,000 words, right? This is ambient, so just normal temperature in the spring, and then this is our warm treatment, where we're warming by 3.6 Celsius, or about 7 degrees Fahrenheit. And this is April 27th. This is a week later, so we see that as we would expect, when trees experience warmer temperatures, that cues them to leaf out earlier. This is now 2 weeks later. So these warm plants have had leaves for, a week and a half, almost 2 weeks longer. By May 18th, we have fully expanded leaves in the warm treatments, and they're just starting to come out in the ambient treatments. So these experiments for pretty much all the species showed this. They're sensitive to temperature, they leaf out earlier. Some of them leafed out up to a month earlier in our worm treatments than some of the others. And when we put this all together, we can think about the cycle of the season, right? We think about bud burst, starting to expand leaves, fully expanded, and then senescence in the fall. And all of these together tells us something about growing season length. One of the things that we didn't have a lot of information about is what happens in fall, right? A lot of these records are looking at spring events. People get excited in spring when it's been winter and want to follow stuff, and maybe are less excited about following what's happening in fall because they know what's coming next. So we didn't really know, what do these trees do if it's a warmer fall. It could be that everything gets shifted forward if they start earlier, or it could be that they respond to temperature too. So this graph kind of pulls it all together, this figure. The blue is our ambient, and this is like when they leaf out and when they lose their leaves. And then the orange is that same leaf out, lose their leaves, but with the worm treatment. And you can see that, as I showed in those images, we have this advance in the spring, earlier leafing, which we expect. They hold their leaves longer, and some species hold their leaves a lot longer in the fall, meaning overall all these species have a longer growing season when grown under warmer temperatures. And that potentially means more growth, more productivity, means positive things potentially for some of these species in terms of forest growth and carbon stored and all the things that forests do for us. Okay, so The third piece of this that I want to talk about brings us back to water and brings us back to citizen science and citizen science monitoring. This is an image of the Twin Cities. How many people are metro area people? There's some of you guys here. What's our metro known for in terms of natural features? Water, we got lots of lakes. Rivers, what else do we have a lot of? Trees and parks. We're a really green city. And we value those things. This is an old image, so you can tell from the car, of our beautiful tree-lined streets that we love. They don't look quite as amazing as when the elms were the street trees everywhere. But, we really value the canopy cover. We value our trees in the city. We also value our lakes in the city. This is Como Lake, an image from up here. This is early season. Anyone know what some of these urban lakes look like by the end of August?
I monitor that.
Pardon me?
I monitor that.
You monitor that lake. Tell me about what this...
At the end of July last year, the clarity was 9 inches. That was the second inch.
So one of the issues with urban lakes is all of what's coming into those lakes and affecting water quality in those lakes. And one of the things that go into them are the storm sewer and the litter that falls into the storm sewer. And I collaborate with some folks who work on nutrient cycling in both terrestrial, in the kind of on the land and in the lakes, and they thought, you know what, wonder how much these leaves are contributing to the nitrogen and the phosphorus and particulates that might be going into our lakes. What do we do with leaves on the street? We street sweep them, right? Yeah, and we street sweep them, I think, for a couple of reasons. One, to keep them out of the water system, but also to keep them from clogging up the storm drains, right? Anyone know how frequently we street sweep the streets? Once a year, twice a year actually. Once in the fall, once in the spring. And so we kind of asked this question, well, when should we sweep? Do you guys know when they sweep? Anyone know when sweeping generally happens?
All year long here.
Well, hopefully when the leaves are down, right? So the idea is that you sweep after all the leaves fall. Anybody know when the leaves start falling? And anyone know if they ever miss the leaf fall? Oh yeah, right? And so our idea was, what if we had people who live on these streets go out and monitor their trees, the phenology of their trees, report that data? Could we learn about the timing of leaf fall in relation to when they sweep, and then think about, is there a better way to sweep, right? A different way to sweep, maybe sweeping that's tied to the biological processes that cause the leaf fall. So we got a bunch of folks in the Como Lake neighborhood actually to go out, and on their daily or weekly or on their daily walks, they basically adopted a tree and they followed that tree over the fall, and we got data from them. And this is what it looks like. How are you guys doing with, I realize that there's a lot of data in here, right? You guys like data though, right? You guys collect data yourselves. So this is kind of like the phenology that I showed before. This is when this is elm. This is when it started to drop. This is when it stopped dropping. So we see that some species start pretty early and drop leaves over the course of 2 months. Some have shorter time frames. Some drop all winter long, right? That's an oak, some of the oaks kind of blah, 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 drop their leaves. This is the estimated street sweeping. So street sweeping might start here on your street, and by the time they get to my street, it's this time of year, right? And so, if you sweep here, you get a bunch of these leaves, but not all of them. If you sweep here, You do pretty well unless these are already gone by the time you get there, right? So these data help us understand really over what time are leaves falling and help us think about maybe there's a time window where we think about sweeping the streets every week over this period. Big cities, that's a hard thing to ask them to do, right? Small cities, that's feasible. The other thing that we've addressed going back to water quality is that not all these species have the same impact, right? Not all these species drop the same amount of litter. Not all these species break down at this as fast or as slow. So some things just break down and all those nutrients disappear down the storm sewer before the leaves get there, or they have lots of nutrients in their litter. So the other thing we've been talking about is maybe, in this day and age, they have really good data on what trees are where. And a lot of streets, the entire street is Norway maple, for example. And if Norway maple is a big baddie in terms of nutrients going into water, maybe we target those streets for sweeping or multiple sweeping. So this project is really aimed at thinking about, one, can we use people to monitor the timing and think about adjusting, even if we do it once, what's happening in that particular weather year. And two, can we rethink street sweeping to do a better job at keeping those nutrients out of our lakes, because it's a lot cheaper to get them off the street with a street sweeper than it is to get them out of the water once they're there. Yeah.
We're monitoring like leaves, the whole fall, people fertilizing in the fall or whatever.
So, yeah, absolutely. So one of the other things that this project is interested in doing, and I'm not part of that, but they are following the kind of entire nutrient budgets of households to say, what do they put in where and when, and which of those are the most important in terms of outputs. And so, yeah, absolutely, that's definitely one of the other big sources. So, hopefully I've given you a little smattering of cool things happening in the state of phenology and why phenology can be interesting from a lot of different angles. I think phenology is important to our biological systems, but they're also important to our human systems, to crops that are important to us, to water quality that's important to us. And so before I end, I want to invite you potentially to get involved with phenology in Minnesota. I coordinate the Minnesota Phenology Network, and we're a group of people interested in both sharing our own personal stories of phenology, but also some folks in collecting phenology data with standard methods and standard protocols. And we've partnered with a national phenology network that has a data and platform called Nature's Notebook that gives us standardized approaches to monitor them, and they maintain an online database, and it's a great program, and it can help, it can address questions you might have about things in your backyard or in your area of interest. It can also support science happening on a lot of different fronts related to the importance of phenology. So thank you very much for listening. I'm happy to take questions, and if you're interested in getting involved with following phenology, like when you go to do your Secchi disc, you could look at a tree right next to your stream and collect the data on it at the same time. This is our website, and you can send an email to me via that site.
So are there studies by your group or any other group done on, say, for instance, what if we had left our streets gravel instead of going to all non-impervious roads? How would that affect what's going into our streams? Would we be better off to go back to gravel rather than having all these tarred and concrete, at least the streets within a city?
Yeah. So my group does not work on that, but there is a big movement towards adding pervious pavement, and pervious, like turning our impervious surfaces into pervious. One of the challenges with that is really it depends on the underlying geology, right? So if you have sand underneath where your driveway is or where your street is, fantastic. You put pervious pavement, you get good infiltration. If you have clay, it's not going to work. And so either you have to engineer it differently, and I know that there's some areas, actually the area we worked in, the Como neighborhood, they have engineered these holding like ponds under the street that infiltrate in place. But that's a kind of an engineering solution. But yeah, there are people working on it largely in this kind of pervious pavement area.
I just want to do a plug for KAXE Community Radio out of Grand Rapids. They do a phenology show with but the other aspect is that they have schools from the area, and it reaches quite broadly because they broadcast in Grand Rapids, Brainerd, and Bemidji, and I think Ely now. But they have kids reporting from, primary school and middle school, and they send in, and they are on radio giving their phenology reports, and it's just a way to engage youth and get them involved in this. And the more I'm thinking about how much, I tune into that all the time, so I think it's just so interesting. But we should do the same thing maybe in the summer. We can get students that would report on what's happening on their lake or what's happening by the river they live on, and just start that engagement on other aspects. But I love the phenology reports. They're great. They're great.
Yeah, so she was just putting a plug in for KAXE, which is the Northern Community Radio out of Grand Rapids. It's also in Bemidji and in Ely, and they, in addition to having their phenology show, they also have a school program. So John Latimer goes out into the schools and gets the kids excited about phenology, and the kids send in phenology reports that are then shared on the radio, and it's a great engagement tool. And she said, wouldn't it be cool if we had kids reporting lake data, lake water quality data to a program on the radio and getting that kind of public engagement from the work you all are doing. Other questions? Yes.
I didn't hear anything about, in your comments about global warming, about the return to the ice age of about 30, 40 years ago. What happened in that time? How did that come about?
The return to the ice age. You mean the little ice age? That they call, like in the 1900s? Oh,
Years ago.
I actually don't know the return to the ice age movement. I might be, maybe I'm not old enough. So folks who are saying, hey, we want to go back into the ice age?
It was fearsome. We were going to all freeze up and be solid, and we wouldn't be able to grow any crops.
Snowball Earth. Thought we were, well, I mean, in terms of the global climate cycles that have occurred, absolutely, we are at a point where on the interglacial cycles, we should be going back towards frozen ice age time in, thousands some years. The data that's out there suggests the global temperatures are not on that trajectory right now. But in terms of those global cycles, that's where we would be going. In the back, there's a question. Can we kill all the cottonwood trees in Minnesota? Oh my goodness. I have a project restoring cottonwood in the floodplain right now. We have an ordinance in Falcon Heights where I live that people can't plant cottonwood because they're a nuisance tree in the city. But cottonwoods are really important in the floodplain forests are critical for bird habitat, for eagle nesting. They're important. Breed them without the cotton, or just keep them out of the city as street trees. I'm getting the hook.
And when we send out the next newsletter, newsletter. We'll send everybody a link to Rebecca's website in case you weren't able to write that down and you're interested in it. So just so you know that. And so at this point, we did want to do a little recognition for some of our Milestone Volunteers. So if we have a few newer volunteers, they may not know about the program. We kind of recognize people in a 5-year or at 5-year marks. So we do believe we have 4 Milestone Volunteers here this year, or at this event today. And so we did want to call the 4 of you up on stage because the time and effort you've put into this program is remarkable. So she's going to pull up the list of you 4, and I'm sorry to put you all on the spot. So, but surprise. Oh, so rotating on the screen here actually is a bunch of our Milestone Volunteers. I think the list was around 200 total, so that we're either at the 5, 10, 15, 20 plus mark. So Lori will call you 4 up here.
And we do have a very small gift for you too. So the first person who I think is here is David Anderson on Ray Lake in Cass County. Yes? And he is a 25-year volunteer. Thank you, David. Yeah, and if you want to stay up here, we would love to take a picture of you all. Yeah, together, that would be wonderful.
We got to get this stuff on our Twitter page.
Yeah, we are Twitter ambassadors at the MPCA, just so you know, our program. So if you have any pictures, send them and we will tweet them for you. Second person is Rolf. I'm going to try and say your name right. Smeeby? Yes? At Phenology Lake in Hubbard County. And Rolf is a 30-year volunteer. Thank you all. And one more lake volunteer who's here, Wayne Conan on Big Swan Lake in Meeker County, and he is a 20-year volunteer. Is Wayne here today? Yes. And I think we have one stream volunteer here who is Mike Glauner, and he's a 10-year volunteer on the soccer. Is that right? Is there anyone else here who is a 5-year volunteer that we may have missed? I just want to... No? Okay. Well, thank you very much. We want to just note that the long-term monitoring is so important. As you just heard from Rebecca, long-term data records are pretty rare and they get more valuable as time goes on. And we're able to just do so much more with that information if you keep going with it. So thank you very much. Kind of running out of time here, but what we were hoping to do, if you all are still game, is to, since we have you here, we'd love to get your input. And what we did is we collected questions from all of you, I think in an earlier email, and we put them on the tables, and we'd like to give you, maybe, should we say 10 minutes? So what we'd like to do is give you 10 minutes each at your table to talk about the questions. If you only get to 1, that's fine. I think I put 2 on each table. If you can cover 2, that's great too. And just, if you write down your thoughts or ideas on those questions. We were going to try and come back as a group and have you report them out, but I think we might not have time to do that. But we will collect the papers definitely today. And, and you'll see on your tables also we have an evaluation. So if you can please fill that out and let us know what you think of the day, how we could improve it, what you liked, what you'd like maybe to be changed. We'd love that too, since this is the first time we've done it. And at 1:55 we're going to do our raffle, so please stick around. Okay, thanks.